Fasten your seatbelts. Generative AI is accelerating the Edge Part 4 by products of the Edge AI plus Generative AI combination. Now that we have watched Parts 1 through 3, we 1. Understand that there are a wide variety of AI model types, and 2. These models can run somewhere on the edge or on the cloud, and 3. We recognize the challenges creating friction in the development and deployment of Edge AI. So, what are the key byproducts that will leverage this new energy and enthusiasm for generative AI and Edge AI? Let's start with the first byproduct, synthetic training. Although transfer learning and base models are becoming more readily available to give companies a head start in tuning and deploying AI models, training AI models for the edge requires a large number of images. For example, to train a camera at self-checkout to recognize a head of broccoli at reasonable accuracy could take north of 15,000 images in the training set and 3,000 images in the validation and test sets. That's a lot of broccoli. As we know, the accuracy of self-checkout needs to be quite high to meet customer expectations. Multiply that head of broccoli by the range of vegetables at your local market and you quickly reach unmanageable numbers. Although you shouldn't train your grocery store AI on generative AI data, hallucinating broccoli, you can and should train it on synthetic data, and then use generative AI to iterate on that synthetic data to create unlimited variations to increase your model accuracy. With use of realistic 3D models, you can generate a virtually unlimited synthetic data set. Synthetic data not only increases accuracy but also accelerates model training. Therefore, you won't spend so much time on data collection and annotation. Extend this approach to agriculture for crop yields, healthcare for medical imaging, or smart cities for training on traffic patterns, and the benefits of synthetic AI model training with generative AI can be profound. A company called Synthetic AI Data out of Denmark that is doing just that with a robust range of tools and services. Let's explore another byproduct, container-based MLOps to the edge. The idea borrows from a growing move to adopt cloud DevOps across solutions, from cloud to edge. The ability to virtualize and containerize AI workloads is increasing productivity from server to server and even cloud to cloud. Now we are seeing several companies innovate to bring that AI workload orchestration to edge devices outside the data center that are either directly connected to the cloud or connected to interim gateways. A few examples. NVIDIA EGX is a cloud-native, software-defined platform designed to make large-scale hybrid cloud and edge operations efficient. Within the platform is the EGX stack, which includes an NVIDIA driver, Kubernetes plugin, NVIDIA container runtime, and GPU monitoring tools delivered through the NVIDIA GPU operator. Cisco has also developed a lightweight distribution of Kubernetes called K3s, which is optimized to run on ARM-based devices. This enables the deployment, scaling, and management of containerized AI inference applications on low-power edge devices. And Microsoft has integrated Azure IoT Edge with Kubernetes to enable the deployment and running of AI, Azure services, and custom logic. Azure IoT Operations is a good example of how this can be deployed. Google Kubernetes Engine, GKE, enables the running of containerized AI workloads at scale on the edge network. The GKE AI ML platform considers the following layers: infrastructure orchestration that support GPUs and TPUs for training and serving workloads at scale, and flexible integration with distributed computing and data processing frameworks. Last but not least, Zadita is a cloud-native edge computing platform that enables the deployment and management of containerized applications and services on edge devices. Zadata provides a secure and scalable infrastructure for running AI workloads on the edge, and an open-source orchestration engine called EVE-OS for Linux-based devices. Keep in mind, the key point with AI workload orchestration is that the container and/or driver is written in such a way that that workload code can actually reach the hardware-accelerated silicon underneath. The virtualization implementation needs to support this kind of hardware access. Conclusions. Now is the time to focus on holistic AI stories. The past year has seen a resurgence of interest and investment in AI as we have reached another threshold in compute capabilities and unleashed generative AI capabilities onto the public. There will be no slowing down as the AI models get larger, the systems get faster, and our appetite grows. Now, as generative AI comes to life, we are faced with incredible opportunities to think holistically about synthetic training, cloud dev MLOps, and real-world scenarios that leverage AI from the cloud to the edge. There's no better time for technology providers, solution providers, and businesses to align their product strategies, partner strategies, and marketing to harness the AI edge, the AI cloud, and everything in between. Thanks for watching. Please subscribe for more Edge Celsius videos.